Hello, students. Today we're going to be talking about ratios. There's rules for ratios and how to put them together. A ratio is a comparison of two numbers. So a ratio is written as 3 to 4 and can be converted to a fraction because the first number becomes the numerator and the second number becomes the denominator. So if we have 3 to 4, it becomes 3 over 4. Ratios must always be expressed in the same units. Thus, it's imperative you convert your data to one specific unit. We'll practice that today. For example, to write 50 minutes and 1.5 hours, you have to convert the hours to minutes so that the items are in the same unit. So it's a lot easier when you go down to the smaller unit too. You avoid decimals a lot of the time. So 50 minutes and 1.5 hours, if I was to convert that right now, 50 minutes to 1.5 hours, what I'd really want to do is I'd want to see the hours in minutes. So an hour is 60 minutes plus a half is 30, so it would be 50 minutes to 90. And that's what we'd have to make sure that we were converting it over, okay? It's easier for comparison purposes, okay? Always convert the smaller units because it's easier to compare. Ratios like fractions can be reduced and must be reduced to the lowest term. So in this instance, we'd actually have to divide each by a value. Well, they both are divisible by 10. So when we reduce that, 50 divided by 10 is 5. And 90 divided by 10 is 9 minutes. So 5 minutes to 9 minutes is what it really boils down to in a comparison. And this will become even more important when we start working with unit rate tomorrow, but it begins with this material. So when we start looking at it, it says determine the following ratios in the classroom and the school. Be sure to reduce your ratio to the lowest terms, just like a fraction. So the ratio of boys to girls in the class. So I would write the ratio right away. It says boys. So I'd put B to girls dot G. That's the format we want to follow. And for the sake of argument, we'll say that there are, let me think it through here. I think there's 10 boys in the class to 15 girls. The problem is I can't leave it that way. It's not reduced. So I would need to divide by 5. So for every 2 boys, there are 3 girls. Okay. Male teachers to female teachers. We could be here all day trying to count that up, but I know for a fact there's less than 10 males in the school. So we'd have Mr. Clark, Mr. Hensby, Mr. Stavina. We'd have Mr. Rivet. We'd have Mr. Mead, Mr. Hansinger, Mr. Frazier, Mr. Diorio, Mr. Reynolds. So that'll give us 9. So this would be, if we look at this one, so this would be males, right? Male teachers, males, to females. I'm going to say that there are 9 males and there are 27 female staff members. I actually think there's more, but that'll work for us what I want to do here. When I look at this, you can tell that this needs to be reduced. 9 and 27 are divisible by the same common factor, and it's actually 9. So 9 divided by 9 and 27 divided by 9. That means for every 1 male there is in the school, there are 3 females. So the male teachers are outnumbered 3 to 1. Okay. State the ratio of junior classrooms to primary classrooms. So in this instance, I would do junior to primary. All right. And we could write that as J to P. Okay. Junior classrooms, there would be Miss Stewart, myself, Miss Mendonça, Miss Bowles, Mr. Rivet, and Mr. Mead. So there are 6. In primary classrooms, there are, if we count the kindergartens as well, let's think. 1, 2, 3. I think it's 12. I think it's actually double. So if we would have, in this instance, we'd actually have to divide because 6 goes into both. So for every the junior classrooms are outnumbered 1 to 2. So for every junior classroom, there are 2 primary classrooms. Okay. So then look at this. So yellow to green. So what we want to do is count up the yellow. 1, 2, 3, 4, 5. So there are 5, 2, 2 green. 3. There's one hiding back here. 1, 2, 3. Green to yellow. So it would be 3 to 5. Same values but reversed. Red to green. 1, 2, 3, 4. And green was 3. Green to all. So that means there are 3 green, and then we count everyone that's there. It says all. So we have 1, 2, 1, 2, 3, 4, 5. 3 to 14. Now, in all of these, I haven't had to reduce yet. These are both primes. 3 doesn't go into 4, and 3 doesn't go into 14. So they're fine. All to red. Well, we know 14 is all. Red, there are 4. So this actually has to be reduced. What are they both divisible by? I would say 2. So we would get 7 to 2. And yellow, there are 5, right? 1, 2, 3, 4, 5. 5 to 14. And that doesn't reduce. Yeah. Okay. Now, this next one deals with hockey. And it's kind of a neat one because we're looking at the ratio. So we're going to take the information here. So it says wins to ties for the Oilers. The Oilers have won 6 games. They have tied 4. So we take that down. They've won 6. They've tied 4. Okay. Done. Flames have lost 7, tied 3. So lost 7, tied 3. Okay. The Rebels wins to losses. They won 7, lost 2. Cougars total games to ties. So total to ties. So the Cougars, their total was 14. And what was their ties? Ties was 4. All right. Now, oops. Now, Cougars wins is 6 to 4. Losses to wins. Losses, wins. So we've got to keep going the same way. So losses is 6. And the wins is 4. And if you look, this adds up. 4 plus 6 plus 4 does equal 14. So that one's done. Did it. So this next one, ratio of Flames losses to wins. Losses, wins. Notice I keep labeling. So the Flames have lost 7, yes, and they've won 2. So what I can do now is add that up, and it actually adds to 12. So I can complete it. Oilers, ties to total games. 4 and 13. All right, because that was ties, and this was total, right? So this is 13. So this is 6 plus something plus 4 equals 13, right? So that means that has to be 3. And these add up. 2 plus 7 plus 3 does give me 12. So we just have to figure this last one out. And it says the ratio of Rebels wins to ties. So wins to ties is 7 to 2. excuse me, ties. That means 2 here, and we add them up. And that gives us 11. So that, ladies and gentlemen, is how you would start decoding it and breaking it down to put in. Okay, and organizing your thoughts as you work your way through. This next one deals with equivalent ratios, and an equivalent ratios is a ratio that represents the same comparison or value. Proportions, a statement where two ratios are equal is called a proportion. Okay, to determine if a set of ratios is equivalent, you must reduce them to lowest terms like a fraction, then compare. To determine the unknown value in a ratio where the ratios are equivalent, but one value is unknown, you must convert the ratios to fractions and then determine the unknown value. So if I was simply to take 4 to 5, I would write it as 4 over 5. And I would go like this, and I'd say this is 16 over something. Right? We don't know what it is. But I can ask you this question. How did 4 become 16? Well, you would tell me we multiplied by 4. And you'd be correct. What we do to the numerator, we do to the denominator. 5 times 4 is 20. And so, ladies and gentlemen, the answer is 20. If we look here, we don't know the first part of that ratio, but we can write this as something over 50. And the question is, how did, and this one was 7 over 25. So the question is, how did 50 become 25? Well, we would have divided by 2. So something divided by 2 is 7, which we know would be 14. And that's how we would get it. Okay? So if we look here, we would write ratios as fractions and work our way through. So let's look at this one. How did 21 become 3? Well, we divided by 7. And what we do to the denominator, we do to the numerator. 14 divided by 7 gives me 2. How did 2 become 6? Well, we multiplied by 3. What we do to the numerator, we do to the denominator, and we get 9. If we look here, we have 18 to 6. Well, we divided by 3. So we have to do that here. 15 divided by 3 is 5. How did 5 become 10? Well, we multiplied by 2. What we do to the numerator, we do to the denominator. This would be 12. Now, an interesting question here. Okay. How did, now this is actually a typo, I think, because this should be 36. How did 12 become 36? Well, we would have multiplied by 3. And we would have multiplied by 3 here, which would have given us 30. Okay? So, and no matter how we work with this, even if we divide these by 2, 30 divided by 2, if we go backwards again, is 15, and 36 divided by 2 is 18. So they are all equivalent. Okay? So the main thing to take from this is that it's the same rules as fractions. All you're doing is you're using it as a ratio. Take the ratio, convert it to a fraction, and you'll have no trouble finding the equivalent values. And the same thing here is just making sure you follow the line of what they're asking in the order. Okay? And it's a comparison of two values, and you should be good to go. All right.